Well, let's talk now to Sarah Cruddas, who's a space journalist and broadcaster, and Paul McMahon, who works for Airbus, which built the Rosetta spacecraft and is responsible for the reaction wheels, which basically control the movement of it. He had to fix them when they failed the other side of Jupiter. We'll get you to explain how you did that in a moment. First of all, though, Sarah, it's been described as Europe's moon landing moment. Really?
Well, absolutely. This is of course, I think we take for granted how much we've done in space, but actually we've done very little. I mean, we haven't left beyond Earth orbit in over 40 years. We haven't sent humans back to the moon in over 40 years, and we've never landed on a comet before until this mission happened. It had an epic journey across the solar system. The technological equivalent of this was to land a fly on a speeding bullet. I mean, at the moment, so that's when we sent the Philae lander down, at the moment this comet is moving at around 14 kilometres a second, and we've managed to send a spacecraft from Earth, which was dreamed up in the mid-1980s, send it to this comet, chase it across the solar system, study about, how life might have come to be. Comets were around at the early solar system. We think they might have actually seeded a very young Earth with water or the potential ingredients for life. We're starting to put the pieces of the jigsaw puzzle together, and we've never done something like this before. So it is absolutely an Apollo moment in terms of exploration, and it's a great moment for Europe as well, because it's just huge, it's just incredible, and there's a lot of people who've worked very hard. It was an expensive mission, but you get a lot of innovation and technology back from that, and it's just a game changer in how we explore the solar system. And it's that next piece in that jigsaw puzzle of asking those really fundamental questions of who we are, where did we come from, why did we exist, is there life, in our solar system, beyond our solar system? And all these questions, as Carl Sagan once said, extraordinary claims require extraordinary evidence, and this is what we're doing. We're beginning to piece together the evidence to answer fundamental questions about our own existence.
Paul, I said that you were responsible effectively for the wheels.
Yes, so on board Rosetta there's 4 reaction wheels which are used to point the spacecraft whenever they want to image something or reorientate the spacecraft to send it on a new trajectory.
And there was a problem with them, wasn't there?
Yes.
It was quite a long way away.
Oh,
so
yes.
Explain what happened.
So after Rosetta flew past Comet Steins in 2008, we noticed that the friction on one of the wheels was increasing. So we had to do some work on it, and we changed some of the parameters, and we managed to re-lubricate it while it was out by the orbit of Jupiter, so that when it came out of hibernation in January 14, they started up the wheels again, and things were running much better.
So presumably that was fundamental. If that hadn't have been fixed, it would have been kaput, would it?
No, it wouldn't have been kaput to the mission, but it would have been a degraded mission, because they wouldn't have been able to use the reaction wheels as they wanted to do, and they would have had to rely more on the thrusters. If you look at the orbit of Rosetta around the comet, it's basically a triangular shaped orbit. So every time the spacecraft goes round one of the corners of the triangle, the reaction wheels rotate the spacecraft to point it in the new direction. So they're working very, very hard at that point.
So you described, Sarah, what has been done as like landing a fly on a moving bullet.
Yeah.
I mean, it really does bring it home when you talk about that. In terms of what's being done today, why is it being crashed into the comet?
Well, it's getting so far away from the comet that its solar panels won't actually get any energy from the sun, enough heat from the sun to keep it awake, and it could be sent to sleep. I mean, Churyumov-Gerasimenko, to give the comet its full name, named after the people who discovered it. It orbits around the Earth it takes about 6 years to orbit around the sun. We could put Rosetta to sleep and maybe wake it up, but it probably wouldn't wake up, and then it might just end up like a piece of space junk, a piece of space debris, and as humans we've always generated waste wherever we go. But by actually, I say crashing, colliding it with the comet at about walking speed, it is the final piece of science of the mission. It's actually a really interesting area where they're actually going to try and land Rosetta. As soon as it lands, as soon as it collides, we won't get any further communication, but we'll get lots of close-up pictures on the way there. And then this spot they've picked, it's a rather flat bit of surface, and there's lots of almost like goosebumps, which they think are cometesimals, so embryos of comets, and it might help us to understand more about how comets form, because you hear of all these words in space like solar systems and comets and stuff like that, but we don't know the exact answers about many things, so it's just helping along the way in terms of science and the potential to come from this. I mean, the amount of research and data and information means that kids who are at school now who might be interested in space, say they become a scientist in 20, 30 years' time, they'll still be studying the data which came from this mission. So it's not over in terms of the research and the exciting developments which are going to come from it.
Very cool. Thank you very much, Sarah and Paul. Thank you.
Thank you.
Thank you.
Get in touch with us if you've any thoughts on that. Now though, let's catch up with the weather with